You're welcome back. So here we're going to be looking at the absolute value of a complex number. Now the absolute value of a complex number is also called modulus. Modulus spelled M-O-D-U-L-U-S, modulus, okay? And sorry, let's go back. Okay, the spelling M-O-D-U-L-U-S, that is modulus, okay? And we usually denote it by either we say this or we just simply represent it as R, okay? So if you have a complex number which is z equal to x plus iy, then the modulus will be equal to the square root of x squared plus y squared. Now what is the implication of this? If I'm given a complex number, let's say to be equal to 2 plus 3i, and I'm asked to find the modulus, it means that the modulus of z now will be equal to square root of 2 squared plus 3 squared, okay? So that is going to be equal to the square root of 4 plus 9, 3 squared is 9, and that is going to be square root of 13. So it means that the modulus of 2 plus 3i is equal to root 13. Let's see another example. So let's say we have this to be equal to 1 plus I, our complex number z is 1 plus I. To find the modulus of z, that is going to be the square root of the coefficient here is 1 squared, plus the coefficient of I is also 1 squared. Here people usually make mistake, they use I. No, you never use I in finding the modulus. So 1 squared plus 1 squared is just the coefficients, just the real part and the imaginary part. So square root of the square of the real part plus the square of the imaginary part. Okay, so this is now equal to square root of 1 squared is 1 squared is 1, so that gives us root 2. Okay, so we move to the rules of absolute value. First of all, the first rule is that the absolute value of z1 plus z2 is less than or equal to the absolute value of z1 plus the absolute value of z2. Please note this, meaning that they are never equal. So never find yourself writing absolute value of z1 plus z2 to be absolute value of z1 plus absolute value of z2. No, it is rather less than or equal to. Actually, for those of you that, that are in engineering or will go deeper in mathematics, that is a triangular law. That's a triangular law. Okay, but we can see that absolute value of z1, z2 is equal to absolute value of z1 times absolute value of z2. Absolute value of z1 over z2 is equal to absolute value of z1 all over absolute value of z2. Then absolute value of z squared is equal to z times conjugate of z. Okay, so you should know that. Now please don't be for this, let me prove this quickly. Remember we said that that when you multiply a complex number with its conjugate, it's going to give you sum of two squares, x squared plus y squared. So that's the same way the absolute value, remember absolute value is supposed to be the square root of x squared plus y squared. So when you now square the absolute value now, is going to just give us x squared plus y squared. It's going to take away the square root. So that is how we now see that the square of the absolute value is equal to the product of a complex number times its conjugate. So whenever you see this, you can just substitute this. It goes, right? Now we see a question here. So this is the kind of questions we can see here. We have z1 to be equal to 2 plus 3i, z2 to be equal to 4 plus 5i, z3 to be equal to 2 minus I. So the first one we asked to find the absolute value of z1, z2 all over z3. Now, first of all, I want to show us how we would have normally done this. When you say absolute value of z1, z2, it means you want to find the product of z1 times z2, okay? Then divided by z3, and you now rationalize. That's going to take a long, in fact I can't even do that in this video, but because I know the rules of absolute value, I can simply say that the absolute value of z1 z2 all over z3, okay, is the same thing as the absolute value of z1 times the absolute value of z2 divided by the absolute value of z3. That's good. So what is absolute value of z1? Absolute value of z1 is supposed to be square root of 2 squared plus 3 squared. So 2 squared plus 3 squared, that's 4 plus 9, which is 13. The absolute value of z2 should be square root of 4 squared plus 5 squared, 4 squared plus 5 squared. That is 16 plus 25. That's going to give us 41. Okay. Then the absolute value of z3 here is going to be square root of 2 squared plus 1 squared. Even if you say minus 1 squared, it's the same thing. Okay, so 2 squared is, that means square root of 4 plus 1, which is 5. Okay, so it means that the answer to this question, your z1 is going to be root 13, okay, times your z2, which is root 41. Now divided by z3, z3 is root 5. Okay, so this is good. So you do 13 times 41 divided by 5. Okay, and root 13 times 41 is going to give us, that's 520 plus 13, that's 533. So that's going to give us root 533 divided by root 5. If you want to rationalize that, to rationalize the sword, we are going to get, that's multiply both sides by root 5 over root 5. Is going to give us square root of 2, 6, 6, 5. Okay, now divided by 5. So that's the answer we get there. Okay, so that is quite easy. Now, if you want to go about it the other long way, which you can try that on your own, you know, I would even like it. You try it on your own and you send me to show that the answer is the same. But just that this method is shorter, since we know the rules of absolute value, the other method will be quite longer. Okay, so let's see the second question here. We are asked to find the absolute value of z1 plus z2. Now, don't allow your village people tell you that this is the same thing as absolute value of z1 plus absolute value of z2. That is a demon. You bind it. Okay, so they are not the same. Remember, it's supposed to be less than or equal to. So now, how do we treat this? You just treat it directly the way it is there. So we can simply say we can write our value for z1. We can find z1 plus z2 first of all. So what is z1 plus z2 is going to be 2 plus 3i plus 4 plus 5i. If you add the real part to and the imaginary part, 2 plus 4 is going to give us 6, plus 3i plus 5i will give us 8i. So that means the absolute value now of z1 plus z2 is now going to be equal to square root of 6 squared plus 8 squared. Okay, now that's going to be equal to square root of 36 plus 64. That's equal to square root of 100, and square root of 100 is equal to 10. Beautiful. So you just go straight if it is addition. But that rule, you can apply it for multiplication, you can apply it for division. Okay, so do this now and send to me. I will check for the first 5 persons and we continue from there. Thank you very much.